All right. On our review, sections 2.7 through 2.8, I got asked to do number 7B. So in order to do 7B, though, we need to know the answer for 7A. I'm actually going to write it over here. But this one is saying find the domains of f and f prime. So that's our derivative, which is from part A. And in part A, you should have gotten an answer of -5 over 2 square root of 3 minus 5x. Okay, so let's just start with finding the domain of f, our original. Function f is a square root function. Okay, you cannot take the square roots of negative numbers. Okay, so in order to find the domain of f, you take what's underneath your radical and say it has to be greater than 0. If I'm bigger than 0, I am not negative, I am positive. Can I be equal to 0? Can I take the square root of this function if it was 0? Yes, I can, so equal to. Then I just need to solve it using inequality rules, okay, or laws of inequality. So I would have 3 greater than or equal to 5x, and then I would divide both sides by 5. So I have 3/5 is greater than or equal to x. It's always better to write the x first, so I have x is less than or equal to 3/5, and then we should put it into interval notation. So less than or equal to 3/5, so numbers less than would be negative infinity up to 3/5. Since 3/5 is included, it's going to be a bracket. Okay. Then we have to go ahead and find the domain of our derivative. Okay, so we're finding the domain of our derivative. Now the difference is here, this was in the numerator. Now my radical is in my denominator. Okay, so I still have the idea I can take the square root of it if it's a positive number. However, if this is equal to 0, I would have 0 times 2 in my denominator, and I cannot do that. So in this case, it is just strictly greater than 0. And we would solve this the same way we solved the other one. And we should get the same answer. However, we will not be equal to. So we divide by 5, so 3/5 is greater than x. So x is less than 3/5. So negative infinity to 3/5. And since we're not equal to on this one, it's a parenthesis. That would be our answer for 7B. I also got asked about number 8. So let's go ahead and look at number 8. The graph of f is shown. State which reasons the numbers at which f is not differentiable. Okay, so we are not differentiable when we are discontinuous. Okay, if there is a corner or a cusp or a vertical tangent. Okay, so first things first is I see there's a discontinuity at -4 maybe. 1, 2, 3, 4. Here's an issue. There's a discontinuity. Can't take the derivative there. So at x equals -4, we are discontinuous, or we can't take the derivative because it's discontinuous. Because f is not continuous. Okay. Then I travel along my graph and I come to this point. It's a corner or a cusp, so we can't take the derivative there. Got to have smooth curves in order to take the derivative. Okay. So at -1, you can't take the derivative because it has a corner. You could also say cusp, either way. Then I continue on. Ooh, looks like there's a little break here. There's an asymptote. I am discontinuous. It's an infinite discontinuity, but all I care about is I can't take the derivative because f is discontinuous or not continuous. And then if I carry on, I think I'd be fine taking my tangent line here, except for if I were to draw my tangent line right here, I would be able to just cross through and have a line straight up and down. That is what we call the vertical tangent. That is the hardest one I feel like for you guys to identify. But if I was drawing my tangent lines, I would have a tangent line that's up and down. This line has a slope that's undefined. And if our slope is undefined, then we can't take our derivative because derivative is the slope of our tangent line. So at x equals 5, we can't do it because f has a vertical tangent. Okay, so there's 3 ways you can't take the derivative. If it's not continuous, if there's a corner or cusp, or if there's a vertical tangent. You are looking out for those 3 cases. If that occurs, then you cannot take the derivative.